Hello everyone. In this video, we shall discuss how to derive the values of the six trigonometric functions or six circular functions given values of specific angles theta. Now we start off by considering the right triangle below. And this is a right triangle because it contains an angle that is equal to 90 degrees. Now if we consider this as our angle theta inside the triangle, then this side is called the opposite side of theta. This one is called the adjacent side of theta. And the third side of the right triangle is the hypotenuse. Now the six trigonometric functions are as follows. We have the sine, cosine, tangent, cotangent, secant, and cosecant. And you can see the symbols for each of those trigonometric functions. So we have here sine of the angle theta, cosine of the angle theta, tangent of the angle theta, and so on and so forth. So if this is our right triangle, and this is the angle theta, this one is the opposite side, this one is the adjacent side, and this one is the hypotenuse. So sine of the angle theta is defined as the length of the opposite side over the length of the hypotenuse. Cosine theta is equal to the length of the adjacent side over the length of the hypotenuse. Tangent theta is equal to the length of the opposite side over the length of the adjacent side. Now, cotangent theta is just the reciprocal of tangent theta. Secant theta is just the reciprocal of cosine theta. And cosecant theta is just the reciprocal of sine theta. So these are the definitions of the six trigonometric functions using the right triangle approach. Now, let's move to the trigonometric functions using the circular approach. So in this slide, as you can see, there is a circle. So we call this the unit circle, having the equation x squared plus y squared equals 1. So this circle has center 0, 0, or the origin, and its radius is equal to 1. Now let us consider a point P on this unit circle. So this point P has coordinates x, y. Now the angle between the positive x-axis and the side containing the point P is called the angle theta. So this is the angle formed by the line segment OP and the positive x-axis. Now the x-axis here is the initial side of the angle theta, and the line segment OP is the terminal side of the angle theta. And the angle theta is said to be an angle in standard position because its initial side happens to be at the positive x-axis. Now, since point P lies on the terminal side of theta, we shall denote it by P of theta, and now we call it as the terminal point of the angle theta. So the values of the six trigonometric functions are defined as follows. So it's based on this unit circle. So the sine of theta, sine of the angle theta, is actually equal to y over 1. So as you can see inside the unit circle, there is a right triangle that is partially inscribed inside the unit circle. So the sides of this right triangle are as follows. And the length of this side is x, the length of the opposite side is y, and the hypotenuse is the radius, which is equal to 1. So the values of the six trigonometric functions using the unit circle are also based on the formulas that we have enumerated earlier in the right triangle approach. So for sine theta, it's the opposite side, which is y, over the hypotenuse, which is 1. So that's why sine theta is equal to y. And then cosine theta is the length of the adjacent side, which is x, over the hypotenuse, which is 1. So that's x over 1, which is also equal to x. And then tangent theta is the length of the opposite side, which is y, over the length of the adjacent side, which is x. And then cotangent theta is just the reciprocal of tangent theta. Secant theta is the reciprocal of x. And cosecant theta is the reciprocal of y. So which means if we have an angle theta, let's say angle theta is equal to 0 degrees. So that means that the initial side of this angle is the positive x-axis, and its terminal side is also this positive x-axis. Now the terminal point, so our P of theta will be P of the angle 0 degrees, or P of 0, and this is equal to the point 1, comma 0. So this means that x is equal to 1 and y is equal to 0. So by definition, or using the definitions of the 6 trigonometric functions using the coordinates of the terminal point, sine of 0 is the y coordinate of the terminal point, so which is 0. Cosine 0 is the x coordinate, which is 1. Tangent of 0 is y over x. So that's going to be 0 over 1, which is 0. Now, the reciprocal of tangent is 1 over 0. So that's going to be undefined. So cotangent of 0 is undefined. Secant of 0 is the reciprocal of cosine, and the reciprocal of 1 is 1. And cosecant of 0 is the reciprocal of sine. So that's going to be 1 over 0, which is also undefined. Next, if our angle theta is 90 degrees or theta is pi over 2, then our terminal point will be P of pi over 2, which is equal to 0, comma 1. So this time, x is equal to 0 and y is equal to 1. So again, following the formulas for the 6 trigonometric functions, using the coordinates of the terminal point of pi over 2, we have the following values. So sine of pi over 2 is the y coordinate, which is 1. Cosine pi over 2 is the x coordinate, which is 0. And then we use these values of x and y to get the values of the other 4 trigonometric functions. Next is, if our angle theta is 180 degrees, or theta is equal to pi, then our terminal point will be negative 1, comma 0. So that means x is equal to negative 1 and y is equal to 0. So again, using the formulas of the 6 trigonometric functions, using the unit circle and the terminal point of pi, then we have the following values. So sine of pi is the y coordinate, which is 0. Cosine of pi is the x coordinate, which is negative 1. Tangent of pi is y over x, which is 0 over negative 1, and that's 0. Cotangent of pi is x over y, which is negative 1 over 0, which is undefined. Secant of pi is 1 over x, which is 1 over negative 1, which is equal to negative 1. And cosecant of pi is 1 over 0, which is undefined. Next, if the angle theta is equal to 270 degrees, or theta is 3 pi over 2, then its terminal point is the point 0, comma negative 1. So this means that x is equal to 0 and y is equal to negative 1. So sine of 3 pi over 2 is the y coordinate, which is negative 1. Cosine 3 pi over 2 is the x coordinate, which is 0. And then the rest will follow based on the formulas and the x and y coordinates. Now, let us suppose that our angle theta is equal to 45 degrees, or theta is equal to pi over 4. So if the angle theta is 45 degrees, so this one is 45 degrees and this one is 90 degrees, then using the sum of the interior angles of a triangle, the sum is 180 degrees, then that means that this angle is also equal to 45 degrees. So which means, using the properties of the lengths of the sides of a triangle, since these two angles are equal, then the lengths of their opposite sides must also be equal. So that means if this is 45 degrees and this is length x, then this one of length y is also equal to the length of the other side. So which means if we're going to use the equation of the unit circle, x squared plus y squared equals 1, then y can be replaced by x. So we have x squared plus x squared equals 1. So we have 2x squared equals 1, which means that x squared is equal to 1 half. And solving for x, we get positive negative square root of 1 half, which is equal to positive negative 1 over square root of 2. And then rationalizing this will give us x is equal to positive negative square root of 2 over 2. However, since the terminal point P is on the first quadrant, then that means we're going to use x equals positive square root of 2 over 2. And since y is equal to x, then y must also be square root of 2 over 2. So the terminal point of pi over 4 or 45 degrees is square root of 2 over 2 comma square root of 2 over 2. So which means that both x and y are square root of 2 over 2. So sine of pi over 4 is the y coordinate, which is square root of 2 over 2. Cosine pi over 4 is the x coordinate, which is square root of 2 over 2. Tangent of pi over 4 is y over x, which is 1. Cotangent pi over 4 is x over y, which is 1. It's because x and y are equal. And then secant of pi over 4 is 1 over x. So that's going to be the reciprocal of cosine. The reciprocal of cosine is 2 over square root of 2. But if we rationalize this, then we're getting 2 square root of 2 over square root of 2 times square root of 2 is 2. So which means that the 2 will cancel out and we're left with square root of 2. So for cosecant pi over 4, it's the same thing because sine pi over 4 is square root of 2 over 2. So its reciprocal must be also square root of 2. Now what happens if our angle theta is equal to 30 degrees? Okay, so if our angle theta is 30 degrees, we can actually draw additional line segments inside the unit circle and this one. So there's another, it's like a reflection of this right triangle that you're seeing here on the first quadrant. So if this is the angle 30 degrees, this one is 90 degrees. So using the sum of the interior angles of the right triangle, then this angle here must be 60 degrees. Now, since this triangle here is just a reflection of the triangle on the first quadrant, then this angle must also be 60 degrees. And this one is 30 degrees. So if we add it with the 30 degrees above, then this angle here is also 60 degrees. So since all the angles, all the interior angles are equal to 60 degrees, that means the lengths of the sides of this triangle are all equal to 1. And this means that this thing here is equal to 1 half. So which means that y is equal to 1 half. So in order to solve for the x coordinate, then we have to use the Pythagorean theorem or the equation of the unit circle. That's x squared plus y squared equals 1. So if we substitute 1 half to y, we get x squared plus 1 half squared equals 1. And that's going to be x squared plus 1/4 equals 1. So if we transpose 1/4 to the other side, we get x squared is equal to 1 minus 1/4, which is 3/4. And solving for x, we will be getting positive negative square root of 3 over 2. However, since the terminal point of our angle 30 degrees is on the first quadrant, then we have to take x is equal to positive square root of 3 over 2. So which means the terminal point of 30 degrees or pi over 6 is square root of 3 over 2 comma 1 half. So using the definitions of the six trigonometric functions and the terminal point, then sine pi over 6 is equal to y, the y coordinate, which is 1/2, cosine pi over 6 is the x coordinate, which is square root of 3 over 2, tangent pi over 6 is y over x. So that's going to be 1/2 over square root of 3 over 2. So if we get the reciprocal of square root of 3 over 2 and multiply it with 1/2, it's going to be 1 over square root of 3. So let's write it down here. 1 over square root of 3. But if we're going to rationalize this expression, we will be getting square root of 3 over 3. Now, cotangent pi over 6 is x over y, so which means that's square root of 3 over 2 divided by 1/2, which is square root of 3. Secant pi over 6 is the reciprocal of cosine, so that's going to be 2 over square root of 3. And after rationalizing, we get 2 square root of 3 over 3. And then cosecant pi over 6 is the reciprocal of sine, and the reciprocal of 1/2 is 2. Now, the derivation of the values of the six trigonometric functions using the angle 60 degrees or theta equals pi over 3 is actually similar with the 30-degree angle. So if this is 30 degrees, then this is going to be 1/2, and then this one will be the square root of 3 over 2. So basically, the terminal point of 60 degrees is just the, if we interchange the coordinates of the terminal point of the 30-degree angle, then we're getting the coordinates of the terminal point of the 60-degree angle. So similarly, we have the following values for the six trigonometric functions using pi over 3. I'm sorry for this error. This should be pi over 3. So all of them should be changed to pi over 3. Now, to summarize the values of the six trigonometric functions, for the angles 0, pi over 2, pi, 3 pi over 2, pi over 6, pi over 4, and pi over 3, we have the following table. So observe that all the angles that we considered here are the axis angles and the special angles. So I hope that you learned on how to derive the values of the trigonometric functions. So we will be needing these values later on in the succeeding lessons or videos. So you need to practice finding out the values of the trigonometric functions without using your scientific calculators. So I hope that you learned something here in this video, and thank you for listening. And I hope that you can subscribe to my channel. Thank you.